Okay, what does triple integral do? It means they integrate 3 times, right? The word triple integral means to integrate 3 times. In what occasion when you have to do triple integral? Then yes, actually many times beyond the volume things really. Okay, so you have a space object in space. Okay, usually a triple integral is defined over the closed solid in space. We call it region G now. Okay, so we usually give a name for a region in space for region G. Right, a region in space, and you integrate over the region G. So how does this look like? Okay, example of region G. Okay, I think it's somewhere here. Okay, you can see this picture here in the notes there. So you have somewhere space. So when you do triple integral, like this, something like this, triple integral over a region. Okay, triple integral over a region here. So the region usually called dV now. Okay, just now in double integral you get area element dA. For triple integral you have volume element now. So a little cube called volume here. So delta volume is this one. So what you have actually is find the little cube inside the solid here. Then the little cube has something defined on the cube. For example, could be a density. For example of this, for example, is a F, X, Y, Z. Could be the density. Okay, for example, the density. So when they multiply by F, Y, Z, multiply by delta V, become the mass. Volume times density become the mass, right? Become the mass of that little cube. Okay, the mass of that little cube inside there. So when they sum up all the little cube, become the volume times density, become the mass of the solid. Okay, could become mass of the solid. So this could be final thing become like the mass of the solid. For example, when you do the mass of solid. So usually there are some implication when you do triple integral. Okay, let's look at some result of triple integral. So you know that for this little cube called x, y, z axis, right? So usually the dV usually can be written as dV here, integrate over the region, space region, could be dz, dy, dx here. There are 6 other variations. Of course, there are many, depend on the limit there. So you can dz, dy, dx, or 6 variation, dx, dy, dz, one possibility, right? dy, dx, dz, another one. All together there are 6 possibilities, right? You write down all the possibilities. There are 6 possibilities. Write down the integral. All of them have the same answer. It's just that sometimes you switch them, you get easier integration, right? Just write a few for you to see, right? Because altogether there are 6 possibilities. For example, you can have a dx, dz, dy, right? This is already 4 already, right? You can add the dy also. Okay, if I put dy in front, then dy, dz, dx. Okay, and R1. I think finally I just want to get dz in front. can get dz dy dx. Right? So these are all the 6 possibilities if you write in this way. Means this is order of integration. Okay, this result is called Fubini theorem. That means you can switch them, it also give you the same result, except that some of the calculation will be more messy. Okay, so let's look at one simple calculation. Okay, simple calculation, how to find the volume of a solid in space, right? So next part here. Okay, find the triple integral now. 12 xy squared z cubed dv over the rectangular box G defined by x from -1 to 0, -1 to 2, y from 0 to 2, and z, y from 0 to 3, and z from 0 to 2, right? So what is this box here? This box actually, if you try to draw it, okay, what is this box here? So x, y, z here, so this x here, y, z. So x from -1 to 2, right? So this is actually positive axis, this behind negative axis, right? From -1 to 2. Okay, so -1 here to 2, right? 1, 2. Okay, x from -1 to 2. Okay, you know that this is all your x look like this. X from -1 to 2. Okay. Okay, let me hold. Come cannot write. Okay. X from -1 to 2. Okay. So come cannot. Don't know why. Yeah. Okay, x from -1 to 2, and then y from 0 to 3, right? Y from 0 to 3, 0 to 3 here, y from 0 to 3, okay? 1, 2, 3. So we draw this one, y from 0 to 3. Okay. Okay, y from 0 to 3, so actually here, all the y here. And then z from 0 to 2. So go up 2 unit. Z equal to here. So everything go up from here. 2 unit. So it looks something like this. So this is the box created. Okay. Basically, it say that this box, this side is 3. This side, okay, -1 to 2 is 3. 0 to 3, this side is 3 here. And then this side is 2. Okay, whatever they're trying to ask you, for example, this number here could mean, for example, if you interpret them, this could be density. Okay, could be density. So actually density times the volume of the small cube here. So end up you find the mass of the whole thing, right? So what you're trying to do now, you can actually direct integration because this is a rectangle. So direct integration now. So this is direct integration is 12 x y square z cube dv. Up to you. You can use dz, dy, dx. Okay. So then you just fill in the limit accordingly. So x from -1 to 2, so the outer limit is x from -1 to 1. So -1 to 2. Okay, the outer limit I put them. Okay, y from 0 to 3. Z from 0 to 2. So you must make sure that these are all corresponding, right? X first, and then this is a y, okay, then this is z. Then z is another one. So change the color. Sorry. Okay. Z, let me use a different color. Not this one. Let me change this one, Z first. Use a black color. Medium point. Okay. Z is this one. Okay, so integrate the inner integral first. -1 to 2 and 0 to 3. Integrate with respect to z first. You get 12 x y square z power 4 over 4. Okay, this is z from 0 to 2. Okay, then move on to the next page. So this is actually -1 to 2, 0 to 3. So this is actually cancellation. So you can cancel this 4 and 3 now. Okay, put z equal to 2, you get 2 power 4 is 16. 16 times 3 is 48 now. So this is actually 48 x y square dy dx. Okay, then continue. Next page now. Insert first. So you're actually from -1 to 2. Okay, -1 to 2. Then 0 to 3, right? Integrate this one, you get 48 with respect to y. Now you get x y cubed over 3 and y from 0 to 3 dx here. So this is equal to -1 to 2. Then this one cancel. Okay, then 3 cube. Okay, so you press 3 power cube is 27, right? 27 times 16 now. So 27 times 16 is 432. So this is 432. Four, 3, 2, x, because all connectively, right? So this is dx here. Then integrate one more time. 4, 3, 2, x squared over 2 now. X from -1 to 2. So this 432 times 4 is 2. 2 square is 4, right? Then afterward, 4x equal to 1. So 42 times 3 over 2, okay, times 3 over 2. Then get the answer 648. Alright, so this is an example of a triple integral, a simple triple integral, where actually, okay, triple integral straight away integrate over a region. Okay. Right. So how? This one 648. Okay, the power of this one. Okay, so first example, a triple integral. Okay, so let me move on.